Welcome to the second part of our survey on software asset management for ZOS and PTracker. In this video, we focus on how PTracker works and what this means for asset management. In the first video, we spoke about goals, demands, and practices. There was also a third video which deals with the integration of PTracker results in the working environment of the purchasing department or contract management. Where does the data that we require to support software asset management come from? There are two data sources. An inventory reveals the installed software, but we still don't know whether the software is ever used or how often. We gain usage data through a continuous recording of program executions. The recording mechanism should capture relevant attributes: program, library, user, job, date, time, and more. Modules, libraries, or products that are not used will never appear in usage data. Hence, both data sources are important: inventory and usage data. Usage data must be continuously recorded, on behalf of which user or job was the module for that library executed. One cannot generally say this program was never executed, but only an execution of this program was not observed within the observation period. Hence, it is important to monitor the execution gaplessly. Only the combination of both data sources provides answers to the interesting questions like, which software products are installed and paid for, but never used? SAM's main objective is to support the commercial use, to ease decisions, to justify upgrade license fees, etc. But once we have collected the data, we can use it to answer various technical questions. There are several fields where SAM data is helpful, with error detection and error prevention, installation management, cleanups, etc. For example, contingency planners, those who think about disaster recovery, can verify their plan for completeness. System programmers might be interested in real usage of modules in linked lists. Security officers might want to monitor the usage of APF authorized libraries, and others. Let's get a bit more technical, so you can get an understanding of how PTracker can help you very quickly to get an understanding of what products are being used and by whom, when, and how often. From what we've learned so far, it is not surprising that PTracker consists of the components inventory and recorder. In addition, there is an identifier, a component that determines the clear names of the applications, products, and vendors from the technical library names and other information. Thus, PTracker can show the clear names in usage and inventory reports. Inventory is a batch job that can be executed at any time. It executes very fast and resource-sparing. Even installations with hundreds of volumes see execution times in the order of minutes rather than hours. Inventory scans the entire ZOS site and delivers the complete list of all currently installed ZOS programs. The recorder can be regarded as a type of monitor system. It records each program invocation, no matter what it is: utility, application, middleware. It is designed to run continuously on each system without charging additional load. Overhead is not measurable. The identifier component executes together with the inventory component and identifies product name, product number, and vendor wherever applicable. A few words on the recorder. Nothing can bypass the recorder. Each executed program or module will be detected, no matter if it is a TSO or batch or whatever. The recorder output is further processed and forms the basis for meaningful reports on frequency of use of the applications. In connection with the inventory, PTracker can also provide reports on programs that have not been used in a certain observation interval. The PTracker recorder is technically a started task. It uses the SAF or SAF exit to capture the relevant invocation data and writes it to a ZOS data space. At a predefined filling level, the output is switched to the second, the alternative data space. The first one is then emptied. Output processing formats the data. The recorder allows filtering to include or exclude libraries you want to be monitored. Counting only is also an option. The recorder allows for simulation mode. In simulation, nothing is externalized. The events are only counted. Run it initially in simulation mode for an hour or a day to size the output datasets accordingly. Recorder data is available as sequential, comma-separated, and other formats. The recorder data layout is fixed blocked. The logical record length is 220. The output of the recorder includes everything that could be desired. See the field list here in gray. As a speciality of PTracker, the caller module in library and the called module in library are available. Hence, PTracker can view program invocation chains too. Fixed field and record length facilitates queries, comparisons, and reporting. Let's have a look at the inventory part. The inventory is a batch job that scans the DASD farm to determine the load libraries. Besides a list of detected libraries, the inventory outputs a member list for each library, as well as a list of copyright and other module text found within the modules. The latter helps to identify the name of the application, the vendor, and other metadata. As I mentioned earlier, the inventory itself is very efficient, requiring minutes rather than hours. This slide gives you an impression of what type of information comes out of the inventory process. On the left side, we see the volume, the type, the PDSE, the library name. In the middle, the copyright information that is found in the modules, and on the right side, the module names of that particular library. Product internally, this data is kept in related tables, library table, text, or copyright table, and the members table, which are related. The process of identification. This slide gives you an overview of the process. As mentioned, the process begins with the inventory, a total scan of all mounted libraries, ZOS disks, for installed program libraries. The modules of the detective libraries are simultaneously searched for copyright particulars and linkage editor text. This program is unbelievably fast. Even big installations with hundreds of the largest volumes experience only minutes of execution time. In a further step, SMPE is interrogated to receive more details on the libraries. This completes then the field's product number, name, vendor, and version for nearly all IBM products and for the products of many ISVs like CA, BMC, CompuWare, etc. In-house developed software is normally not installed and maintained through SMPE. Therefore, PTracker comes with an identifier, an ISPF-based program that enables the administrators to quickly insert the in-house clear names of the applications and the corresponding version number. The identifier is also applied with licensed software that is not SMPE installed. On a side note, sometimes there is the question, how can PTracker's identifier detect the libraries and the applications, although the CSE files or SMP files are only available in the installation area, not under test or production? The answer is, PTracker has a duplicate detection. It can recognize that the same library of a different name in another system is the same, because of this duplication detection. Now let's assume we've done the inventory and have the recorder up and running for some days. We have inventory output and some days from recording. Now we can start with reporting. We can see what is installed and what was used so far by the various users. The results can be viewed as a simple sequential tables or as a comma-separated text files with spreadsheets. This is how it looks like for the PTracker administrator. Under number 1, we can request another inventory. Number 2 allows to merge different inventories. The last one with the new one from different systems. Number 3, Edit activates the editor to complete or modify the product list. With number 4, we can activate a specific product list for reporting. Some remarks on PTracker's editor. The purpose of the editor is to complete the product list. As we saw, the product list was created by the inventory, that is, Volume Scan Plus SMPE processing. This is an automatic process. Here we have a product list under the editor. We see some lines completely filled. These are the libraries that were SMPE installed. Everything is fine with them. Wonderful. Have a look at the first 4 lines these gaps still need to fill. Obviously, these ACM libraries were installed without SMPE. We can now use editor commands. For example, the filter command, to filter the list by library name with the name pattern ACM. Lines not having ACM in the library name vanish from the panel, except those that are duplicates of them with changed names. Next step could be, show the copyright information on these libraries, ACM and duplicates. Thereupon, we already obtain, in most cases, vendor name and product name. We can now use the assign command to assign vendor, product name, and version to all those lines by one keystroke, so to say. This way, the license and applications are accurately identified. The result is again a 100% precise and complete product list as a reliable base for meaningful reports on usage or non-usage. From customer experience, we know that this indispensable work takes them from 2 hours up to 2 days, depending on the background of the admin and the complexity of the company structure. How everything plays together. As we said, there are again the 2 data sources. Inventory begins with the scan of the ZOS volumes to collect the libraries and to build an initial product list. SMPE processing improves the product list. The PTracker administrator uses the editor to complete the product list with the entries of the non-SMPE applications, especially in-house apps. At the end, we have one or more product lists or inventory tables, depending on the structure of the company and the according reporting demands. On the other side is the recorder that collects continuously the events, for example, program invocations. The post-processor formats the event data and output into the event tables. Both inventory tables and event tables form the base for PTracker's reporting. As a summary, the components and their execution frequency. Thank you for listening. There is a further video that finally brings in the harvest as it deals with the usage reporting, frequency of usage, non-usage, as well as the data transfer to procurement and contract management. Thank you.